From the figure below, what is the radius r of the circle? Hence, find the length of the line y. If you are ready, let us solve it. Label points C, B, D, H, Q and join lines B, C and Q, D respectively. Using cosine rule and substitute values. Simplify and we have that the square of BC equals 48 subtracted from 159 is equal to 112. Find the square root of the equation. Using sine rule, substitute values, and simplify, we have that angle beta equals the antisine of the product of 3 divided by 2 and the square root of 3 divided by 7. Also, join line HC. Mark the center of the circle O and join. OC equals O, H equals radius r of the circle. Since we have gotten the value of angle beta, reflex angle HOC equals product of 2 and angle beta. This is because the angle at center is twice that at the circumference of the circle. Please note it. We will come to that later. But angle HDC equals angle BDC subtracted from 180 degrees, which is equal to 60 degrees. From triangle HDC and using cosine rule, we solve for the square of HC. Simplify to get that. Square of HC equals 189. From triangle HOC. Using cosine rule, we found a new value of the square of HC. Substitute the value of angle beta and equate your result with equation I. Make the square of r the subject of the formula and we have that the square of r is the combination of given values and our derived values. We are now solving for question I specifically. Find the square root of the equation and simplify to get that r is the square root of 49, a perfect square root of number that simplify to 7 centimeters. Therefore, r equals 7 centimeters. Using the value of h, b given, we reconstruct line G, C equals to h, B and join H, G and B, C respectively to form inscribed rectangle in a circle. GB equals 2, R equals diagonal of the rectangle. Since R equals 7 centimeters derived, and considering triangle B, C, G, we use Pythagoras theorem to find length BC. That is the square of G, B equals the sum of the square of B, C and the square of G, C. So that, by solving for the square of B, C, we have that B, E equals to 147. Find the square root of the equation to have that. B, C equals the product of 7 and the square root of 3. Construct line K, E equals to line BC. Opposite sides of rectangle KBCE are equal. BC equals K, E equals the product of 7 and the square root of 3 in centimeter. Hence, substitute values and we have that KF equals the sum of the product of 7 and the square root of 3 in Y. Label W and join line HW. Also, join line BE. Label angle H, the center angle equals angle delta equals angle E, the center angle. Reason is that angles in the same segment are equal. From triangle W, H, K. The ratio of y to 3 equals tan delta. Also, from triangle BEK. For divided by the sum of the product of 7 and the square root of 3 and y equals to tan delta, since tan delta is equal in both triangles. This implies that by equating the values of tan delta, cross-multiply and rearranging terms in one side of the equation, we have quadratic equation in y. Using quadratic equation formula, we solve for y by substituting coefficient terms of the equation and simplifying. We have that y equals the ratio of the sum of the product of -7 and the square root of 3 and the square root of 195 all divided by 2 in centimeter.